We're told that a particle moves along the curve x squared y squared is equal to 16, so that the x-coordinate is changing at a constant rate of -2 units per minute. What is the rate of change in units per minute of the particle's y-coordinate when the particle is at the point 1, 4? So let's just repeat or rewrite what they told us. So the curve is described by x squared y squared is equal to 16. They tell us that up there. They tell us that the x-coordinate is changing at a constant rate. Let me underline that. The x-coordinate is changing at a constant rate of -2 units per minute. So we could say that dx, I'll write it over here on the right-hand side, dx dt, the rate of change of the x-coordinate with respect to time, is equal to -2, and they're saying units, be some unit of distance, units divided by minute, units per minute. And what they want us to figure out is, what is the rate of change of the particle's y-coordinate? So let me underline that. What is the rate of change of the particle's y-coordinate? So what they want us to find is, what is dy dt? What is that equal to? And they say when the particle is at the point 1, 4. So when x is equal to 1, so x is equal to 1, and y is equal to 4. Y is equal to 4. So can we set up some equation that involves the rate of change of x with respect to t, y with respect to t, x and y? Well, what if we were to take the derivative of this relation that describes the curve? What if we were to take the derivative with respect to t on both sides? So let me write that down. So we're going to take the derivative. Actually, let me just erase this so I have a little bit more space. All right. And so that way I can just add it. So let's take the derivative with respect to t of both sides of that. And if at any point you get inspired, I encourage you to pause the video and try to work through it. Well, on the left-hand side, if we view this as a product of two functions right over here, we could take the derivative of the first function, which is going to be the derivative of x squared with respect to x. So that is 2x. And remember, we're not just taking the derivative with respect to x. We're taking the derivative with respect to t. So we're going to have to apply the chain rule. So it's going to be the derivative of x squared with respect to x, which is 2x, times the derivative of x with respect to t. So times dx dt. And then we're going to multiply that times the second function. So times y squared. And then that's going to be plus the first function, which is just x squared, times the derivative of the second function with respect to t. And so once again, we're going to apply the chain rule. The derivative of y squared with respect to y is 2y. Let me do that in that orange color. It is equal to 2y. And then times the derivative of y with respect to t, times dy dt. And then that is going to be equal to the derivative with respect to t of 16. Well, that doesn't change over time. So that's just going to be equal to 0. And so here we have it. We need to simplify this a little bit, but we have an equation that gives a relationship between x, derivative of x with respect to t, y, and derivative of y with respect to t. So actually, let me just rewrite it one more time so it's a little bit simplified. So this is 2xy squared dx dt plus, actually I don't even have to rewrite it again. All we're trying to do is solve for dy dt. So let's actually just substitute the values in. So we know we want to figure out what's going on when x is equal to 1. So we know that the x's here are equal to 1. This x squared, well, that's just going to be 1 squared, so that's going to be equal to 1. We know that y is equal to 4. So this is going to be 16, and this is going to be 8. We know the derivative of x with respect to t is -2. They tell us that in the problem statement, -2. And so now this is a good time to simplify this thing. So this will simplify to, let's see, all of this is going to be 2 times 1 times -2. So that is -4 times 16. So that is -64. And then we have And then we have, let me do this in a color you can see. And then we have all of this. Well, this is just going to be 1 times 8 times dy dt. So this is going to be 8 dy dt. So plus 8 times the derivative of y with respect to t is equal to 0. Add 64 to both sides, and we get, I'll switch to a neutral color, 8 times the derivative of y with respect to t is equal to 64. Divide both sides by 8, and you get the derivative of y with respect to t is equal to 64 divided by 8 is just 8. And if you want to look at the units, it will also be in units per minute. Some units of distance per minute. And we are done.